Hi, this is Katie. Welcome to Online Math Tutorials. Today's topic is expansion and compression of functions. Expansion is stretching an object, making it wider, and this can be done horizontally and vertically. Compression is like squeezing an object and it's making it thinner. And this also can be done horizontally and vertically. When you're doing expansion or expanding by a factor of 2, that means you're multiplying by 2. And compressing by a factor of 1/2, for example, and that means you're multiplying by that number 1/2. Let's take a look at horizontal expansion, compression, and after that we're going to go over vertical expansion and compression. If you want, you can call it HE for horizontal expansion and HC for horizontal compression. Horizontal expansion or compression, they happen when the x variable is multiplied by a constant, and that is happening inside the function. Which means when you are given with f of x as the original function and transformed or horizontal expansion or compression is happened, then your function will be written as f of k times x. Here the k is the constant, which means it's a number. It can be a fraction, decimal, or even integer, but it is actual number. It's not a variable. So this value will tell us whether it is expansion or compression. So in other words, it will be a squeezed inside or a squeezed thinner or stretching out, making it wider. So let's take a look at some examples. Y is equal to x squared transformed as y is equal to 3x squared. As you can see, the variable x is multiplied with 3. X becomes 3x. So that means it is horizontal expansion because the 3 is multiplied to the x. On the other hand, when you have the y is equal to x squared becomes y is 3x squared. The 3 is not multiplied to the x. 3 is multiplied to x squared according to the BEDMAS. So when you have the multiplication and exponent has to be applied first. So that means the 3 is not multiplied to the x. 3 is multiplied to the x squared. So this is not for horizontal expansion or compression. So this is not the right one. Let's take a look at a few more examples. So y is square root of x is the original function, and that is transformed to y is square root of 1/4x. So we have a constant number, which is 1/4. That is multiplied to the x. So that means x becomes 1/4x. So that is the right form for horizontal expansion or compression. And again, once again, if you have y is equal to 1/4 square root of x, this 1/4 is not multiplied to the x itself, it is multiplied to the square root of x. This is not the right form for the horizontal expansion or compression. Let's look at actual example that's for horizontal expansion or compression, and we'll take a look what happens to the function or the graphs. We've got y is equal to absolute value of x. That becomes y is absolute value of 2x. So x becomes 2x. Let's start with the table of values. X, Y. Let's start with -4, -2, 0, 2, 4. So if you take the absolute value of x values, y will be just the +4, +2, 2, 0, 2, and 4. And if you draw or sketch the graph for the first function, -4 and 4, -2 and 2, 0 and 0, +2 and 2, 4 and 4. So it will be V shape with the straight lines, like that. Let's make table values for the second function. Since there is no change to the y variable, we're going to keep the y values the same. So it will be 4, 2, 0, 2, 4. To have these values as y, we're going to find what x can be inputted. X can be input. To have the 4 as the y, x can be +2 or -2, but let's start with -2. -1, 0, +1, and 2, like that. Okay, so let's plot these points. So this is the x. So let's plot these points on the same grids. So -2 and +4, -1 and +2, 0, that stays the same, 1 and 2, 2 and 4. So I used a different color. So green one is for the second function. Y is absolute value of 2x. So as you can see, there is horizontal. So this is a horizontal because the blue function, the original function, is squeezed inside in this direction. And that is for horizontal compression because the function is getting thinner by a factor of 1/2. And the k value here is 2. Here's a question. What will happen if k was 1/2? Okay, how about we sketch the graph for k is equal to 1/2. Okay, so let's draw let's make table values for this one as well. Let's keep the y values the same, 4, 2, 0, 2, 4. So to have the 4 as the y, it has to be 8 for the x. So we'll be maybe starting with the -8, -4, 0, 4, and 8. So maybe we can plot the points on the same grid in the previous example. I'm going to copy that to the previous page. That is for y is absolute value of 1/2x. Okay, I'll use purple this time. So -8. So since this is over our grid, so let's start with -4 and 2. -4 and 2 is over here. Positive 0 and 0 over here. 4 and 2 right over there. Okay, so as you can see, the graph, the second graph, y is equal to 1/2x, absolute value of 1/2x, will be wider. So it's expanded instead of compressed when the k is 1/2. And that is expanded by a factor of 2. It's doubled. So when the k is half, the graph is doubled. When the k is 2, the graph is shrinked by half, which is 1/2. So you can say horizontal expansion by a factor of 2 when k is 1/2. Let's summarize the horizontal compression or expansion. y is f of x is transformed as y is f of kx, k times x. So k will give us the idea what kind of transformation is. So for the compression or expansion. So when the k is greater than 1, for example, positive 2 in the previous example. So when k is greater than 1, then horizontal compression is happening by factor of 1 over k. And when the k is in between 0 and 1, so we're not gonna look at the k value as negative, because when the k is negative, that means it's the reflection. So we're gonna look at the k value, only the positive k value for compression and expansion. So when the k is between 0 and 1, in other words, k values as 1 over 2, 1 over 4, or 1 over 8, so something less than 1, then it's for horizontal expansion by factor of 1 over k.